Hello again. I recently purchased this Tektronix CFG250 2 MHz function generator on eBay. It was sold as not working as is, and there's no output. So today I looked and I plugged it into my oscilloscope, and for sure there was no output. This light does come on though right here, so that means the fuse is still good. It has all these different dials, they all work. There's no broken knobs or anything on there, so that's good. The frequency adjust is very smooth, so looks like the front panel is still working, so that's good. Yeah, it's in pretty good condition overall. So I just wanted to make sure, I just wanted to open this thing up and see if there's anything that's obvious inside that's wrong, that we can make this work again, since this is a very nice small unit. Okay, looks like it's got 4 screws on the bottom and 2 ones on the side, and those are only screws I see on the case, so it should be able to just crack open after those screws are out. Let's unlit it and see what's inside. Wow, look at that. All through hole like expected from the 80s design. Nice switches right there. See, it looks like we got the power supply section right here, and then the transformer for the power supply section. Looks like there's some more fuses down there, so we could check those, because there's an external one, but there's 2 internal fuses too. So that might be a good first check, just to see if the fuses are okay. I don't see any blowholes in any of the components, so that's good. In case you want to know, those are Fuction brand capacitors. Never heard of them, but they look like they're not the cheapest one out there. Looks like there's some linear regulators right there. LM317. Oh, yep. PIP32B, or an 8. Looks like a B. Whole bunch of trimmer potentiometers everywhere in the board. Just a ton. Lots of diodes right there. It's kind of interesting. Just loaded with wires. Look at all these wires all over. Just a big rat nest of wires. It makes it a little hard to see the board, but we can kind of get the gist of it. Looks like there's some nice metal can transistors right there. Some nice little anodized heat sinks. That's pretty interesting. And all the source manuals and schematics are available online. I'll link them down below, just for your enjoyment. It seems like it's a pretty simply made unit, but it look like it's pretty effective based on the quality of the components and the quality of soldering. They didn't really skimp too much on this design. They use black anodized heat sinks, which is very, very nice. You can get away with using non-anodized heat sinks, but they're less efficient to dissipate heat in the environment. So that's a nice little touch right there. So, well, on first glance, those fuses look like they're good, but let me take a look at those in more detail. Those fuses are still good, I just checked them. Okay, well, let's check the voltages on those. Linear supplies are your next step right there. Okay, well, it turns out that this one is actually a transistor, and this one is still the LM317. but that's actually a transistor, so I don't know what that's doing. Look in the service manual for it. Alright, I'm going to go check the LM317 quick, just to see what kind of voltage is coming out of it. Okay, well I did a very basic check on the LM317, and I found that the voltage was like 1 volt on the pin 2 and like 2 volts on the pin 3. So that's very odd why there'd be so low voltage. And there's also a 100 something millivolt ripple on pin 2 and about 230 millivolts ripple on pin 3. According to the datasheet, pin 2 is output and pin 3 is input. So that's a very low voltage going to the regulator, which leads me to suspect that something further before the regulator has gone bad. So let's take a look at the circuit diagram from the service manual. Okay, so over here is the main line voltage right there. Goes through fuses, power switch, and then through the transformer that we've seen. Okay, well then it goes through this diode bridge, and then filter and capacitors are over there, and then it goes directly to the LM317 regulator. So we could check the voltage at this diode bridge and see, I guess we already did, that the voltage is low at this node right here, meaning that it should be 30 volts, but it's actually only 2 volts. That's a very significant reduction in voltage. So I wonder if the diode bridge is dead. It's not working anymore, or one of these chips on there is pulling it low, pulling the voltage low on this rail so much that it's only 2 volts, which would be quite significant. It could also be that one of these capacitors has shorted out on this line. Let's check the diode bridge and see if the voltage coming out of that is good or not. Okay, well the diode bridge measures at 27 volts, so it looks like that's good. But I was checking the LM317 wrong. I actually was checking it. There's on the soak screen on the circuit board it says common on the adjust pin, but actually there's a resistor going between the common and the adjust pin on there. So I was measuring that actual node. I was measuring this node right here instead of the actual ground. Okay, I just unplugged the unit, and this transformer is just smoking hot. It's about 100 degrees C, about. So that's something that's very bad. Ow. Let that cool down a little bit. Wow. Yeah, these wires are... Is there anything hot in the circuit that's just burnt up? This is unplugged now, so. Ooh, ow, that's hot. Ooh, that's hot right there. Wow, look at that smoked resistor under there too. This package is really hot, and also this resistor looks like it's smoked. Looks like some other resistors are burnt too in this stage right here. I don't know what it's doing, but we could check on the service manual and see. I might go ahead and just replace the LM317 to see if that was a problem in the circuit and it caused the over voltage conditioned on these devices over here. Yeah, this is just the output amplifier on the datasheet. and all those components are all burnt up. Or they look toasted, at least. So there's some big value resistors or high temperature dissipation resistors that are all burnt up. And this transistor right here is also burnt up looking. You can see the anodization on the aluminum is all discolored compared to the other one, which is just totally matte black. And this one's kind of like a light brown color. That kind of caught my eye. It also looked like that someone else was repairing it before me. There's a whole bunch of flux residue on the board that looked like it wasn't original. So I went ahead and checked this with a multimeter on diode setting, and between these two pins, right there and there, there's a short of like 17 ohms both directions. So the base to emitter is shorted out on this transistor, and that's what was causing the temperature rise on it. And that might also explain why the 15 volt rail is 30 volt rail was connected right to the 30 volt rail. Alright, so there's a short between these two pins right here, these 2 points. And this other node is unaffected pretty much. You can see like oxidization, it's like green on the base of those pins. Interesting. And while the other one is still, looks like it's still working. It's still like metal plated or something, while the other ones are all like corroded. That's interesting. I wonder if water got in there or something and just messed it up. Okay, I went ahead and took off the heatsink on it, and it's really discolored. Wow. The discoloration on the metal. And that's after cleaning it too. Just really discolored right there too. In a very specific spot. Okay, well, I open up that transistor, and there isn't very much in it. It's very tiny pieces of silicon in there. Tiny, tiny, tiny. There's 2 bond wires that go over to the die. And that's what those green pins were. Must just be the insulation from the case. Then the third one is just connected right to the case through the bottom of the semiconductor, where the connection would be made. I don't know if it's very hard to see on camera. Hopefully you can see that. It's just tiny, tiny, tiny. But yeah, that's pretty interesting. Getting a replacement part for that pretty soon, hopefully. I don't really like how they design all these cables going off to these places on the circuit board, because these ones right here, they're the same color, and they're right next to each other, so it's very difficult to figure out where they went back to. Luckily, I took pictures of the circuit and figured out from the pictures at where they should go. Also over here, there's 2 identical connectors right there, one with a red enamel wire and a black connector, and one with just a natural color wire and a black other black ground connector apparently. And those, I had to look at the pictures again to see which ones went where. So that was pretty, I mean, it's inconvenient if you didn't take pictures beforehand. So that's just something that isn't the best about this function generator. But I got it back together, right? And also these cables over here, they're unmarked where they should go after you take them out. And I, again, have to look at the pictures to see where they went to. And that's just one of the advantages, taking pictures of every circuit board you take apart, just to make sure you put everything back in the right place. So let's power this thing up and see if the 15 volt rail is back at 15 volts. There's something getting hot. I'm unplugged the circuit now. Okay, looks like L1 got pretty hot. L1. Look in the schematic and see where that. Okay, L1 is comes out the 15 volt line and goes through a 10 microfarad capacitor to a filtered 15 volt rail. So something is shorted out there too, and it's kind of suspicious that that inductor just suddenly got really hot. Usually it wasn't smoked before, and now it's getting hot for some reason, which is very strange. I wonder what is shorting that out. Okay, well, I might have been measuring the ground wrong. I found this ground, like an earth point on the silk screen. I might have been measuring at the negative 30 volt rail accidentally on the diode bridge. It's actually the other side of the bridge isn't actually ground. It's actually minus 30 volts and plus 30 volts, and usually they ground one side, and the one side is just like a single-sided supply, but they have plus and minus 30 volts coming out of the transformer through the diode bridge, and they must center tap it to create a ground on the transformer. So I might have been measuring from the negative 30 volt rail on the multimeter. So, well, the output of that was 5 volts, and it should be 30 volts. So there's something that's a direct short to ground, maybe on the 30 volt rail, and that's pretty suspicious that that inductor smoked all of a sudden too. So I wonder if one of those chips is getting hot on the board. To take a little look at the what part is getting hot, maybe. Because I already removed one of those transistors which is shorted out. Maybe there's another thing that's pulling that node down. And I checked across this capacitor, and it was sitting at about 200 millivolts, which is pretty suspicious because this 15 volt supply is sitting at 5 volts, and it's going through this inductor and through this little tantalum capacitor. So if that's sitting at the 200 millivolts, that's sitting at 5 volts, that means maybe the shorts on the 15 volt rail 1, which is look like it's a LC filtered circuit, just to provide lower noise and off the main supply. And the only thing that I've seen that uses a 15 volt supply 1 is up here. If you can see that. Okay, now I've just disconnected that inductor just by desoldering the leg of it. And I'm just trying to isolate the short, because there's only a small amount of devices connected to 15 rail 1, and that would shorten the list of things to check. Okay, well, I plugged it in, and the 30 volt rail is back online. So there must have been something on the 15 volt rail 1 that is shorted out, causing the voltage, the raw output voltage off the bridge rectifier to drop to 5 volts. And I guess we can check the 15 volt rail now to see if it's back online. Well, the 15 volt rail looks like it's good, sitting about 15.5 volts. So the 15 volt rail 1 is definitely pulling the voltage down. Something on it is, to check it out. Okay, well, if it isn't something active like a transistor, maybe it's one of these tantalum capacitors which is shorted out. This blue capacitor is like the only one on the board that looks pretty suspicious. It might have shorted out or something. I think it's a tantalum capacitor, and those sometimes short out if they get old. That's pretty much only one of that kind on a board, so I'm going to desolder it and see if the short goes away. Okay, now that the capacitor is removed, let's measure the resistance of it. And what do you know? It measures 0.5 ohms. So this capacitor right here has actually shorted out due to some either like age condition or something that just shorted this capacitor out. Well, since this is shorted, I'm going to go ahead and replace it with a similar tantalum capacitor. I think I've only got surface mount ones, so I'm going to look through my junk drawer to see if I've got a similar one. It's a 25 microfarad 10 volt tantalum. Okay, here's a complete repair of the shorted out tantalum capacitor. I stood it up on its end because this capacitor's footprint was a little bit too long to surface mount it across the two pads on the PCB. So I just stood it up on its end and put a little wire going over. It should be good. It's a pretty solid connection, so. And I measured the 5 volt rail now, or the 15 volt rail, and it's at mega ohms, so the short's gone. So that about wraps up this video. The voltage rails are all good now. The plus 30 volt rail across the bridge rectifier is at like 30 volts. The 15 volt rail, the positive 15 volt rail at Q15, which is the LM317 regulator, is also good. So the next step would be to check for waveforms, the DC offset, but that requires the output transistor to be inserted. And unfortunately I don't have one that is compatible, so I'll have to order that. But it should come in next week sometime.